it's an honor to have Matz here. He made a 22 hours flight yesterday. So please welcome Ruby creator Yukihiro Matsumoto.
Okay, working. Good morning, everyone. The English presentation always makes me nervous, but some of you understand my feeling. The Euruko is very great conference as always, and except for a few things, I lost my baggage again. Last year, the airline company sent my baggage to Oslo. And this year, they lost my baggage in London. And but this is much better since I will get my baggage midday today. Last year I got my baggage after the conference. Anyway, I had one more serious problem. I forgot my AC adapter, and my battery ran out in 22-hour flights. So the guy up there lent me a AC adapter for my laptop, so he saved the conference. Praise to him. Yeah, could you stand up? He did. As you might know, my country, Japan, is very uniform society. Everyone has black hair, black eye, and the Asian face, and of course, and everyone speaks Japanese. And in the United States, it's a little bit different. Everyone speaks English, but but there are white guys, black guys, Asian guys, and there are some Native American guys, and some the little bit diverse, but basically they are uniform in the speaking language. And in the Europe, it's kind of chaos. but diversity, I believe diversity is very good things to enhance evolution or improvement. So I very interested in the things happens in Europe, and that's the reason I attend the Euruko in sequentially, and so this year I'm gonna talk about the things we've got and the things we will get. Okay. The first I'd like to talk about the Moore's law. Maybe you know about the Moore's law. The Moore's law is the law which is presented in the papers in 1965, more than 40 years ago, the year I was born, and it says that the number of the transistors in the LSI doubles every 18 months. It's exponential growth. This is exponential, like this. And then that means the computer grows exponentially faster and cheaper and with more capacity. Then we were very influenced by this law. The whole society, whole universe, the whole earth, whole humankind was influenced by this law. Then we got the faster computers. PCs are faster than supercomputers of 20 years ago. Like in 1964, we had the first, said to be first, the computer named ENIAC, and it had a capacity to calculate the 5,000 times in a second. Like it's 0.005 MIPS. million instruction per second. And my computer, and it's said to be the 4,388.96 million instruction per second. So it is the 877,792 times faster than ENIAC, in a sense. And this is my first computer. It was a pocket computer in 1980, and it had the 4,424 steps and 178 memories, which is the number of the variables. So it's about 1.6 kbytes in memory. And my first PC was things like this, and it was a 32 kilobytes memory, and no hard drive. And you see that? This is the 8-inch floppy disk, 8-inch, that big, with 320 kilobytes memory capacity. And my computer has 2 gigabytes in memory and 160 gigabytes of the hard drive. So it is 97,089 times bigger than 32 kilobyte RAMs. Okay, and my first PC was the 228,000 Japanese yen, which is the €1 is about the 130 Japanese yen. So yeah, go figure. And we can buy the EPC in the about €300 or something like that in Europe, and it's about for 40,000 Japanese yen. So, and the cheap computer means now everyone owns computers, the personal computers and cell phones. Recently I bought the iPhone. It's quite an interesting gadget, and yeah, to tell the truth, I feel like I need more freedom in the iPhone. So I sense like that I was controlled by the Apple company in DRM and things like that. But but it's a cool gadget anyway. And the iPhone is a computer, and it has a music player and the phone device and the personal information management and a lot more, and games like that. Yeah. You know iPhone is a computer. Recently, my daughter, I bought a cell phone, usual cell phone, Japanese cell phone, to one of my daughters, and this is typical Japanese ones, but it's not like only like a phone device. It has music player ability and it has web browser in it, and even JVM on it. She plays the JVM games on the small cell phone. So it is a computer in a shape of the cell phone. So everyone has a computer and everyone is connected. We had broadband ability, ADSL, fibers, and Wi-Fi like this venue, and we have mobile networks. So everyone is connected now. So now we have the computers faster and cheaper and ubiquitous, and it connected. So that influence in programming as well. And Moore's law changed the software complexity and the programming languages themselves. And now no business can be run without software. So we have the airline company that screws up send baggage into the different city, and or the airline company relies on the computers, and this venue is run by computers. Virtually everything is run by computers right now. So we need more software, more and more software. So in these days, every business, even no relation to the computers, relies on the software. Like the transportation company, FedEx, relies on the computers. And yeah, merchandise company like a supermarkets relies on computers. So everyone's if they want to start new services, they might need to develop new software for them. So they need more software. And but the budget for creating new software is very limited because they don't sell software to sell themselves. So they need to the more software in cheaper and quicker. The when I started my programmer career in I don't know 1990, and it was some kind of the government project that spans the several years. But in these days, web software like you have to develop websites in maybe 2 3 weeks, and you have to finish it in the for 14 days, the 2 weeks instead of 2 years. So now we have the software demand for cheaper, quicker, and more complex and more reliable software. So if you have any bugs in the stock market software, it is huge problem. And then, but unfortunately, Moore's law doesn't apply to humans. We don't grow our capacity. So we need more productivity and efficiency, especially in development. And productivity means obtaining development efficiency at the cost of the runtime performance. The computers are even faster, so we can abuse the power of the computer to enhance our ability to develop software. I'm going too fast. And like the things like this is that, for example, dynamic typing. The dynamic typing, the language with dynamic typing tends to be slower than static typing language like Java, C++, but it is more flexible than its counterpart. So the dynamic typing or duck typing is the example of the abusing computer power to enhance our productivity. And the garbage collection that Java has and the some language has is another example. And in I don't know 20 years ago and 30 years ago maybe, and the Lisp and Smalltalk was the only language that has the garbage collection, and then everyone the modest programmers tend to be the ban garbage collection since they are slower than the manual management, memory management. But the technology enhanced, and then Java changed the whole scene. And Java was very slow at the time they appear, but it has garbage collection, and everyone put their resource to enhance its performance, and now Java is one of the fastest language in the world. So, and change the typical image of the garbage collection performance. So, but with garbage collection, we don't have to manage and track the memory and the objects we allocate. So the garbage collection can remove our burden to track them. So it enhances our productivity. So we don't have to worry about the typical memory leak. And then, okay, the dynamic dispatch or object-oriented programming is another example. And we cannot do any new things with object-oriented programming. So if you can write any software in object-oriented manner, so you can write the same software without any non-object-oriented language. So it does not give us any new things, new features. But but by object-oriented programming, we can model the problem, and then we can organize the systems, and we can handle the more complex software. So it enhances our the ability to create new software. So it whole purpose of the object-oriented programming is to enhance our productivity. So and we knew the productivity not from machine power only, but from design. So that's the reason we choose the language and an API. And productivity by design comes from the good syntax design and good library design, and that combines into what we call API. The API is very important. API is kind of like the interface between the systems and systems, or systems, computers, and the humans. Like it's it's in general, it's an interface between systems, and humans included in as a systems in the development environment. And API is a language and a guideline. What I mean by the API is a language, and the API is not only the set of the functions we can call, or the definition of the structures we set up, but API is the rule or syntax to describe the problem, and it also ingredients for solutions. So you can cut off your button when you have a proper design API for the task. For example, why we use Rails? Just because Rails is a set of the functions and the framework for the web development, so that we can cut off the button of the development of the website. So we don't have to care about the connection with the HTTP server, or the database behind the model stores. So you can concentrate on the business logic, or the site design you have to create. So in that way, the API, or the interface between systems, is very important. But not the API is not only an ingredient, and the API can be a guideline, and reducing unnecessary tasks is very important. So, and yeah, Rails again. Rails is an example of this kind of this API. Not only Rails provides you a feature you need, so Rails forces you, so that how you develop the website, but following that Rails way, so you can be comfortable with developing website. It's kind of like a DSL for website. So domain specific language for website. So you can do the things that the Rails provide. So you can be happy. If you don't want to follow the Rails way, you choose the hard way. It's kind of like that. So the interface, or the API design, or DSL, whatever, can be inspire developers, like guide to the good way of the programming or development. And the programmers tend to be very lazy. the according to Larry Wall, who developed Perl, it it has three virtue. One of the three greatest virtue of a programmer is being laziness. And the programmers are very lazy. They want to cut off their tasks, and they don't want to repeat the same task again and again. So so the principle of dry, don't repeat yourself, applies here. And if you can do the things in short way, not counted in the the number of key types, but in a number of concepts you have to spend. So the Ruby and then its class libraries and the Rails inherited from Ruby helps you to concentrate on the things you really have to do, and cut off the things you may want to do it, but you don't have to do it, and like that. You know, if you write, if you have Java experience, you have to do the lot of things you really don't need it. That's, for example, the static public void main or something like that, or a lot of annotations or the XML files, the huge XML files on the. But you don't really have to do that. But you can cut and copy from previous experience. But you know, but why cut and paste? It's against dry principle. So if you don't have to do, you don't have to do. So the basic principle of design is cut off the burden of the programmer. So this is the design principle that I have followed for last 15 years to design the language named Ruby. So the we are lazy, so we guess what you want, and we want you to do more tasks with less code. So we use sometimes half-mind encoding, like the things we have often is in short tasks. Like you may use the method named P in Ruby. It's incredible, in both ways. P means nothing. It's just an alphabet, but it prints object in a formatted way, a human readable formatted way. So in debug session, we use a lot of the debug prints. So I do often. So I encoded that particular method in one letter. So that's half my encoding. So things we have often should be done little code. Like if you want to open files and read the whole contents into memory, so you can have a file dot open file dot read the path name, so you have the whole contents in a file in less characters. So, but we are not perfect, so we are not omniscient. So we have to care. We can't do we can't design the perfect API at the first time we design. So the very important is we don't put the bad assumption in API. So some guys in 40 years ago assumed that we need two digits for the years is okay, and it happened Y2K problem, and 32-bit int is good enough for represent the time since in a second since 1970. We're gonna have the year 2038 problems. You know that? You don't know that. Okay. In Unix, the time is represented by the second since January 1st, midnight in 1970 in UTC, but it expires in January 19th, 2038. So you can't have any time tick after the year 2038. It's only it's less than 30 years since now. So we are having very serious problem in 30 years from this bad assumption. So you you have to care. You don't need you can't design perfect API at the first time. You have to really care about not introducing bad assumption, bad restriction like that at the first time. So it is very serious. It might be very serious problem, just because systems will survive far longer than you expect sometimes. And yeah, working on languages made me think things that very often. The languages tend to have very longer life cycle than typical applications. Like you don't use any software in I don't know 5 years of age. You don't use any application 5 years ago. You have to version up to the newer version, and no, we don't use Multiplan right now or the Lotus 123 anymore. But the language tends to live longer. Like we do use Fortran and COBOL in year 2009. So, and I assumed Ruby survives the 20 more years, I guess. So I try to not introduce the bad assumption like this into the language, and I encourage you to do the same when designing your system. So you have to allow evolution and start small and grow. The systems grow bigger and bigger, and you have to prepare the half-mind coded the convenient method according to the use case. So without knowing use case, so you can't do the good design. So since I am a programmer and the first user of the Ruby language, so I knew very well about the programmer, and I especially target programmer me. So I started Ruby small and evolved into the use case I met. So that's what I have. And one more important thing is naming is pretty important. And on I don't know the Native American tradition, the true name is very important, and it's so important that they don't reveal their true names into anybody to anybody else, but very close relatives. So just because the person who knows the true names have a control over it. So the naming is very important. If you design systems or behavior or features, which you cannot decide the proper name of it. So I think you can throw it away. You don't have to do that because you don't understand what you need to implement. So you can name it. I don't know, half of the design is already done. If you name it right, and I think the name is pretty important. And if I didn't name Ruby a Ruby, so Ruby is not as it is. So I think it disappears now, right now. So Ruby is a proper name for the language I designed, and the things happens. The naming it is very important. And what have you got after the good design and API and in the right current situation? It's Ruby. So when I designed Ruby 16 years ago, the computers are slow. It took me, I don't know, half hour to compile whole Ruby interpreter, and it was fast more than it is now. Maybe 1/10 or very small, but it took me 20 minutes or 30 minutes to compile. And yeah, we don't have web then, but and but situation, the fast computer and cheaper computer and web system is tend to be, yeah, the the trend goes into Ruby. So we were lucky. We were pretty lucky. So what we've got is Ruby. And okay, I am going to talk about the future. So we are getting even faster computers and even cheaper computers, and we have more cores. And two yeah 2 years ago, multi-core in a laptop is kind of, yeah I don't know what, kind of, yeah, like dreams. But we right now we have the two cores laptop, yeah, right now in the table, at the table. And yeah, we can buy the 4 core laptops in appliance stores. And we have millions of computers are all at hand. You can use the millions of computers by buying services from EC2 or Amazon Web Service. So what we will need is even faster Ruby and multi-core Ruby and Ruby for clouds. Is it possible? I think it's yes. But it's matter of resource we put. Yeah. In 1995, Java was pretty slow, dumb slow, and everyone claims that Java is as a language so-so, but it's too slow to do serious tasks, and you can use Java in business, and 15 years ago. But now everyone uses Java in business. Java get faster, and its ability enhanced, and its backward compatibility is incredible. But just because the big companies like IBM, Sun, or Oracle, and many companies put in the resource on Java or JVM to enhance its performance and ability. So I think it's matter of resource to get the future Ruby, but not in an enterprise way, but in an open source way. So the example is JavaScript. Recently we had a very drastic improvement on JavaScript, and JavaScript is very most common language. Every browser has it. So you have virtually everyone has 2-3 JavaScript implementation. Like even my daughter's small teeny cell phone has JavaScript in it, along with JVM, and it's gained importance recently due to the Ajax stuff, and then JavaScript is basically a dynamic object-oriented language, so it shares the same difficulty of performance with Ruby. So if we can run JavaScript faster, the same technology can be applied to Ruby as well. And we have the faster JavaScript implementation like V8 for Google Chrome, and Squarefish for WebKit, Safari, and TraceMonkey for Firefox. And they run brazenly fast. It's fast. And the technology behind this fast implementation is the tracing jet or polymorphic inline cache or specialization. And they are known. They are known for years, but no one before put g- enough effort for put it makes the dynamic language fast, except for some commercial Smalltalk implementation. So I think fast Ruby is matter of resource, and we have the 1.9 is very fast for comparing to the old implementation, but we I think we can make it more faster, even more faster. And for multi-core Ruby, we have some obstacles. Well, 1.8 uses green threads, so user level thread cannot use the multi-core in an interpreter. And 1.9 uses the p threads, which but along with giant lock. So you can run the single native threads at a time by at a time, just because it's pretty tough to make the core interpreter the thread safe. But we already started some projects, but like the multi VM projects, so we can prepare the multi VM in the process, so that you can the fork off the VM, which is the totally independent. So assign that VM into the threads, so you can do the some concurrent task, you can use the multi-process to use multi-core. Like web system is an example. The web system is very easy to use the multi-core by forking off the service provider, and we can do some kind of the thread aware NRA. NRA is the array of the numbers, which can do the faster number calculation. But I think we can do. This is not started project. This is the vaporware. The thread array NRA is a library that uses some kind of technology like a thread building block to enhance the number calculation. And multiple resource as well is a model resource. And Ruby for clouds, and the web is general multi-process, and we can use the Hadoop. Use Ruby on Hadoop, just because Hadoop can be connected with any language, like a CGI-like technology. And we have some kind of MapReduce like systems in Ruby already, and it's getting improvement. And there might be the distributed key value store, maybe the technology for clouds. So I think there's a huge room of improvement in the community of Ruby. So we will get far better Ruby than it is right now. But we have a lot of work for the future. So I think we need your work. I mean, we need you, not in the sense that military does, but we need the more systems written in Ruby, and the more libraries written in Ruby, and the more experiences shared in the community, and the more experiments to make it faster or to make it to update. And we need more core developers. And what I admit there are some kind of the communication problem in the core developers in Japan and in America and in Europe or in other countries. But I think we can improve this communication and enhance and improve the Ruby language and the Ruby implementations. And I'm really open to any proposal and the advice and any request. pretty often, and contact me at the Ruby core mailing list. Oh, so as a final out, lifecycle of the languages is very, as I said before, is very long comparing to the other programs, and it spans decades. And for, we don't have to rush, so we already have the good language, so you have to keep a steady move. We have to improve step by step, so we keep being better and a good community as a whole. And if the most important things we shouldn't stop. If we stop, the open source community is stopped, and it will be no longer attractive. So everyone leaves to other languages, other projects. So we have to keep moving to be attractive. So right now, I believe Ruby community is attractive, and I wanted to keep being attractive for the future. So I will do the constant move, even though it might be slow, but I will do the constant step to get the better language and the better implementation, and I will not stop improving the language and the community and software. Okay. Oh, it's the last slide. Okay. It's about all of my presentation, and I really appreciate you guys to join the community and join the conference. This is a great conference, and thank you to Anticipated, and thank you for inviting me for the conference. Thank you. Oh, thank you.
Yeah, there. Okay, just 1 second, please.
We are working first. Okay. What would you consider the biggest problem standing in front of Ruby, or its biggest flaw?
What is the biggest problem?
Yeah. What do you consider the biggest obstacle that Ruby has to overcome in order to survive and to get better, to reach all the goals?
Actually, I don't see any big problem in the future. So yeah, we have some problem of some kind of the multi-core utilization, or the concurrency, or the performance for some fields. But it's the Ruby, basically Ruby is good enough for our typical use. But we'd like to enhance the world of Ruby, so we can live in Ruby for every task. I don't know, 10 years ago when I wrote the first book, so Ruby is not good. I wrote Ruby is not good for big systems, like tens of thousands of lines. But right now, they work on very huge systems in Ruby, and very complex and number crunching systems in Ruby. For example, in Japan, some universities working on some weather forecasting the research in Ruby, and they run Ruby on supercomputers. And they wrote the calculation task in Fortran, and controls Ruby controls these routines by Ruby for explanatory web forecasting. So, the things changes, and Ruby is good enough for most of the tasks. And but world is getting bigger and bigger. The Ruby is very popular in the bioinformatics field, where the huge sequence of genome and process sequences. But they are doing pretty well good job. But they won't complain if they have faster Ruby. So I'd like to do Ruby improve Ruby to solve these small obstacles. So performance is the biggest area. We have biggest room for improvement. So say performance in a very various way, and I haven't investigated by myself yet, but development support by some kind of type inferencing is kind of interesting field as well. Like recently we had the project named Diamondback Ruby, which is the kind of the type inferencing Ruby interpreter written in OCaml. They're pretty interesting technology. So I have to investigate these things too. So in a sense, the keyword for the future Ruby is the scalability. The scalability for huge systems, scalability for high traffic or something like that. So we have to discuss every small problem step by step. Did I answer your question? Yes.
Hello. In order to support multi-core, do you think the Ruby syntax, the Ruby language will have to change to support that?
I don't think so. I don't think so. The Ruby syntax is pretty generic, and the all purpose to support even the multi-core Ruby, and it can be done by the libraries or the implementation on top of the current syntax.
What do you think about other implementations of Ruby, like for example JRuby, which benefits from the JVM speed?
As long as I have control over the language, so I'm fine with it. actually, the JRuby guys and the Rubinius guys are our friends. So my friends, my personal friends. So we have very good relationship between, and I admit I can improve the communication between the teams, but yeah, we are in good relation.
Hi. This kind of goes along with the last question, actually. So besides JRuby and Rubinius, does Rubinius even exist anymore? There.
Yeah, it
there's
does.
Also, does it? Okay, thanks. There's also Iron Ruby and all these other things, and I guess what I'm really wondering is, will all the teams come together and make like, some kind of really technical spec that you will all adhere to in the future, or something like that? I don't know if that made sense.
Well, I have kind of mixed feeling on that. JRuby and Iron Ruby is on top of different platforms, so that's different story. But we see our MRI teams and the Rubinius team basically shares the platform, like So yeah, it's kind of mixed feeling. Like we can do the work together to enhance more quick, more faster. But you know, the diversity is very good things, and do they need to? Yeah, Rubinia's team want to do some kind of drastic approach to make it better. I I don't generally mean faster though, but make it better. So the our team took the more traditional and the conservative choice in a design decision, and the Rubinius teams tends to took the drastic change, like the throwing out the interpreter at the once and rewrite them again and again or something like that. So so if because since I believe in the diversity, so I think it's good to have multiple implementation that can be compete. This and yeah, the cost of the developments is the cost we have to pay to keep diversity and encourage evolution of the language. Is it okay? There. Oh, there.
Okay, I'm the negative guy again. Talking about different implementations of Ruby, aren't you a bit of afraid by Microsoft embracing Ruby into their Silverlight and supporting Iron Ruby, because they have a pretty well established record as company that likes to screw up technology that they embrace?
Yeah, as far as I know, I know some people behind Microsoft Ruby team, and they don't they haven't took any action to embrace the language. So actually I'm working on the writing working on the writing some kind of a spec, the written spec for Ruby language, and we formed some kind of the committee to discuss about how we describe the language or something like that, and the person from Microsoft is one of them. So we work in a pretty good manner. So I'm not afraid to Microsoft to embracing the language. Yeah, they're working pretty good as far as the Ruby goes.
What inspired you to create Ruby? Did you just want a technical challenge, or did you hate the other options out there?
Pardon?
What inspired you to create the language? Did you want a challenge, or did you hate the other alternatives?
Yeah, I have been the language geek since I first met in programming. So I really interested in programming language in general. So I learned I started basic, and I learned Lisp, Smalltalk, and C, C++, and a lot of language. And but you know, none of them satisfied me. Probably just because it's not invented here syndrome or something like that. And I wanted to design my own languages, but you know, I wasn't a good programmer, good enough to make up my own language. And I studied the computer science in the university. I had some experience in the profession as a professional software developer. So I learned stuff, and I started creating Ruby. So Ruby is not for, unlike other languages, Ruby is not for solving specific task or something there. Just it's a result of my desire to create my own language and to solve my own task and my own satisfaction. This is very personal too, but you know, it's very surprising to see Ruby to serve you guys. You know, there are people all around the world, and but you know, probably the programmers share pretty much in common all over the world. So that if when Ruby is a good tool for me, probably Ruby is good for tool for you guys too. That's the reason.
Any more questions? Good. So thank you very much.